Okay, today we are working on 2.3c class activity, talking about proportional triangles and slope. To start off, I want you guys to have this open on your desks, have out your pencil, and I want you to copy down the things that I talk about here. I have up the teacher one, so anything in red you can write down, but I won't have you write everything down, but those are all the answers or certain things that I'm going to talk about. So as we look here, it says number 1, it says on the line to the right, choose any 2 points that lie on the line. Let's go ahead here and find one, maybe the one that goes through right here. If I keep following this up, maybe another one goes through here. There's several. In fact, I may just draw just a few just to help us out here. I don't know if you can see these ones. I need to make my dot bigger here. So pick any 2 of these and go ahead and draw a right triangle. If you look over here in the example, then you go straight up and straight over from one to the other. So you pick 2 points. If I was going to do this one, I'd go straight up and straight over. That's a little hard to see, so I'll pick a different one. And straight over like that. So do it here. In fact, it wants you to be able to discuss with someone else in class. Instead, go ahead and draw 2 different triangles from one to another. So you might pick another one where it goes through right here and up to like right there. 2 different triangles that look like that. Then I want you to answer a couple of these questions on number 2. So it says, how are your triangles the same? So look at them. Are they similar? Explain to me how. How are they different? Explain to me how. Again, these triangles are what we call similar triangles. They look the same, they're just a different size. So they're similar to each other. And we know from the last class activity, 2.3b, that we didn't finish in class, that similar triangles are proportional, or they have proportional side lengths. And so that's the relationship that exists between these 2 triangles. Here down here in the bold it says, given any 2 triangles where their longest side, this side here on your 2 triangles, is on a given line, and the other 2 sides are vertical and horizontal like this, then there is a dilation from one to the other. That means there's a factor between them. One's going to be bigger than the other. That creates similar triangles, which means that their legs or their sides are going to be proportional. Let's move down and let's go to the next page here. On here it says the graphs given below have several different triangles formed when 2 points lie on a line. The triangles are dilations of one another, and their corresponding parts are proportional. So we're going to write the height over the base. And for these triangles, the height over the base is basically the rise and the run we've been talking about. So if you look in this first triangle, we have this big triangle. It says it has a rise of 13. So if you counted that, you get 13. And if you count over, you're going to get 13. And 13 over 13 is 1. Then we go to the next triangle and we go up 10, over 10. So rise of 10, a run of 10, 10 over 10 is 1. And then we do it again, a rise of 7, a run of 7 is 1. And here we have a rise of 1 and a run of 1, which is 1. Then we're going to do it over here on the next triangle here. So we go up 5 and right 15. Rise of 5, run of 15, simplifies to 1/3. We do it on the next one. It's a rise of 4, a run of 12. The next one is a rise of 3, a run of 9. A rise of 2, a run of 6. And all of those simplify to be 1/3. Let's do it 2 more times here. On question 5, we're going to rise 12. We run 6. That gives us 2, or 2 over 1. We rise 10, run 5. We rise 6, we run 3. We rise 4, we run 2. All of those simplify to be 2 over 1, or 2. And then finally on this last one, you rise 7, you run 7. You rise 3, you run 3. You rise 4, you run 4. You rise 2, you run 2. All of these equal 1. So number 7 says, do the ratios always simplify to the same fraction? The answer is yes. The lines that create the triangles are dilations of one another. These dilations make the triangles similar. They have parts that are proportional, and so their ratios are going to be equal. So these similar triangles are going to have equal ratios, and that's what we found with, like, they were all 2s, so they are all 1s. Number 8, how does the rise over run ratio describe the steepness of the line? The higher the number, the more steep the line is. So if you look on 3, 4, 5, and 6, number 5, it came out to be a 2. 2 is bigger than 1 and 1/3 and 1. And notice that it's the steepest line. So the bigger the number, the steeper the line is. Go down to number 9 and 10. We're doing it again now. There's a difference between these two. This line is going down where this line is going up. So it's kind of like our falling and our rising. And so here, our rise is 9, our run is 12. 9 over 12 is 3/4. Our rise of 6, our run of 9, 3/4. Rise of 3, run of 4, 3/4. Over here, it's the exact same. 9 and 12 is 3 over 4. 6 over 9 is 3 over 4. 3 and 4 is 3 over 4. So they have the same ratios, but they're different lines. One of the lines going down from the left to the right, the other line's going up from the left to the right, or it's falling and it's rising. They have the same ratio because they're the same steepness. If you did a mirror image between 9 and 10 here, the lines would go right on top of each other. So how can we differentiate between the slopes of these lines? Well, we need to make a ratio for the line that's going down negative. And I talked a little bit about this with the ramps yesterday, is that the line is negative when we are falling, and the rise is positive when we are rising. How does the rise related to the run of a negative slope affect the steepness of the line? It doesn't change it. The negative slope only tells us the direction the line is going, which means it's falling. But the steepness of the line is the same, and that's why these on the left for number 9 are all 3 out of 4, and the ones on the right are all out of 3 out of 4. It's all the same slope. The negative just tells us it's falling. The positive tells us it's rising. Okay, if we come down 14 and 15 here we have two different lines, so we're going down 12 and right 4, so it's negative 12 over 4, which gives us a negative 3. It's falling, and so it's a negative slope. We have negative 6 and over 2. We have negative 9 and over 3. We have negative 3 and over 1. They all equal negative 3. Over here, negative 15 and 5, negative 12 and 4, negative 6 and 2, negative 3 and 1, all of them are negative. So here it says, are the ratios of graphs 14 and 15 positive or negative? And so these ones are negative. This makes the entire ratio negative. So why are the slopes for graphs 14 and 15 the same if they're different lines? The steepness of the line doesn't change. They're both the same steepness. They're placed at different points. Like this one goes through 0, 0, and this one would cross way up here. So it's situated on the right side of the graph, but they still have the same steepness, which is represented by this negative 3 slope for both of them. All right, get out your 2.3c homework and go ahead and start drawing in your slope triangles and counting, and good luck.